Welcome to everybody. We want to speak a little bit about coordinate transformation inside of Civil 3D. And we were working with NTV2 files, a special point in Civil. My name is Thorsten Scheel from Quantitas, and this is my profile. I'm an application engineer for AutoCAD over more than 38 years experience, and therefore I'm one of the most senior application engineers worldwide. Since 33 years, working as a programmer and application engineer for infrastructure and GIS. I also have extended the work in conception and maintenance for TopoBase and Autodesk Maps 3D industry models. 27 years I have experience in document management on different systems. And for more than 10 years, I'm an employee of the Quantitas GmbH in Werden in Germany. So let us start with the theme. At first, when you're looking at transformation of coordinates inside of Civil 3D, you find that there are two different ways of transformation in it. The first one was the parametric transformation. Possible are 4, 6, 7 parameter transformations. And here is an example for 7 parameters. The first one was moving along an axis for X, Y, and Z. The next one was rotating around the axis for X, Y, and Z. And the 7th parameter was a global scaling. The coordinate accuracy becomes greater the further you go to the edge of the zone of the projected coordinate system. And there are problems with the transition between two zones. This depends on the projected coordinate systems and their definition. The second way of transformation was the affine transformation using NTV2 files. For that, you need two corresponding point grids. They are required. The point distance must be constant in each direction. So in X, you can have a different one than in Y. That's not a problem, but inside the direction, it has to be constant. For each NTV2 file, you have to define definition area, and the point is valid for this file when it is inside the definition area. You can use at the same time a couple of NTV2 files. They can lay side by side, they can be stackable or overlapping. And it is a good style to define a fallback transformation when the point you're searching for is outside of every definition area. The possible coordinate accuracy depends on the distance between the point grids. Let us now have a look at the technique and why using NTV2 files for transformation. The National Transformation version 2 was defined in Canada. The format and the method are general and are supported in many GIS programs. Instead of the date transition through the 7 parameter transformation between projected coordinate systems, this is done with NTV2 by adding shift values to the ellipsoidal coordinates. The exact amounts of the coordinates to be transformed are determined by linear interpolation within the grid. The clue for the accuracy of the NTV2 transformation depends on the homogeneity of the area. In Germany, we often use the beta 2007 NTV2 file, which have a grid wide of about 11 kilometers. When we use this, we have a currency in submeter or decimeter. In some areas, we can achieve a currency in centimeter power. We have a different GSB file with a grid wide less than 5 kilometers. We can reach an currency in centimeter. And when we use an NTV2 file with a grid wide less than 500 meters, we reach millimeter. So you see, depending on the grid wide of your file, you can get better results. That's the reason to implement own NTV2 files with a smaller grid width. Grid files in NTV2 format usually have the ending ASC or GSA. Both are ASCII, or also allowed is the GSB format. It's a binary storage. Autodesk Civil 3D and AutoCAD Map 3D can only use the binary NTV2 files. ASCII formats are not mentioned. In Germany, is the beta 2007 NTV2 normally in use for the transformation between the German coordinate system Gauss-Krüger and the European ETRS 89 UTM. This NTV2 file is integrated in Autodesk Civil 3D and Autodesk Map 3D by default. When you use an NTV2 file, the transformation is working in 4 steps for each point. The projected source point is transformed to the ellipsoidal, not projected, lat long coordinate. The second point is check if the lat long coordinate is inside the definition area of this NTV2 file. If not, it is using the fallback transformation with the original source coordinate. Shifting the third step is shifting the transformed coordinate using the NTV2 file to the target coordinate in lat long. And the final step is the shifting ellipsoidal lat long coordinate is transformed to the projected target coordinate to get the final point. These 4 steps are produced for every point to be transferred. When you use, for example, a line, it takes 2 points. So both points will be transferred. And the line was drawn, the result line was drawing between the 2 points. So how can I implement a new additional NTV2 file? When I want to do this, I have a little example at this point. At first, we have to copy the new GSB file to the right place. For German GSB files, place it to the directory Program Data Autodesk Geospatial Coordinate Systems. This point 14.08 and the subdirectory Germany. The number in the path may be different. It depends on the version of the Civil 3D you are using. And you see in the right in the picture where the place is. And in this example, I copy the GSB file Contilos inside the directory. So let's have a live look on how to implement it in the system. The command we need is to call the coordinate system library coming with Silvus 3D to you. So there are two possible ways to reach it. First, we can get the normal command line and give it the command. Another way is to change the working area from Silvus 3D in planning and analysis, going to map setup, and there in this place you find the library. And the command for that, you see it in the command line, is map CS library. The next step is to unselect all filters, and we select the geodetic transformation. The coordinate system library is available over all coordinate systems in the world. So we have to set also a second filtering criteria. At this point, DHDN, to get the German coordinate system. Now we select normally the second one, because the second one is working with the beta 2007 GSB file. The first entry you find cannot edit directly. You can view it, but when you view it, you will see it's in parametric transformation. So we select the second one, go to edit, and get a new formula in which we have to select grid data file interpolation. Here you see the beta 2007 GSB file. The next step is important, and you have to do it first before you try to add the new file. You have to define the file format. And in this case, we selected Canadian NTB2. Important is that you, in this point, select the extension, the possible extensions for the adding files. The next step is pushing the plus button. Now we have to go to the place where we copy the new GSB file, in this case, Germany. And we find Contelos GSB. We open it and it is added. Now you have, in this case, two GSB files. And important is the ranking. When searching for a GSB file and proving the area, it started at the top, it goes down. The first GSB file who has the right area was hit and all others are ignored. Therefore, we have first to go to our GSB file with the finer grid, and with the error button, we move it on top. Okay, then we have a little look at this point for the fallback. We can say, okay, we didn't need any fallback transformation. When we do this and we find a point, it's outside the definition area, then this point was ignored, or also the object that the point depends to. When we define a fallback transformation, then we have the chance to get about the select knob, the select button. You see we are going to the normally coordinate system library and can select whatever you want. Normally, you use parametric transformation at this point. Okay, that was all. We go to save. And you see at this point we have both GSP files, the right ranking. We say close and can also close it here, and all was fine. But we have also a look what we have to do when you need a transformation and why it works like this. Sorry, I selected the right one, but the system don't want like I. So I want a short view how to use. To show you, I selected also the geodetic transformation path. That was the way where the transformation works. Before I do this, we first look at the projected coordinate systems. No, okay. Here, that's the filter criteria for searching, and we find that every coordinate system was mentioned 2 times. You see here, and also nearly the same under it. But the second one has in the name the beta 2007. Not 2007, but beta, it means the same. At this point, you select when you assign the source coordinate system if it is using the parametric transformation or the affine transformation. When you select the simple one, you will use the parametric transformation. When you want the affine transformation, you use this. Saying assign, and that was it. When you selected the beta one, let's have a look again on the geodetic transformation path. Let's have a view. So what you see is from top to down the geodetic transformation used. And the first one you see in the top was the one we added our GSP file. When this transformation is proceed, it will proceed the next one in the list of transformations. And on this way, you see the source datum here. That was the reason why this transformation path is used. So first, define a geodetic transformation. You need it, then define the path and the coordinate system using this path. Okay. The next question need sorry, my PowerPoint don't want like I. How to produce our own GSP file. Also, on this point, we will have a little bit live. Doing this, we change the drawing. In this drawing, we have an area, normal drawing, and we need now a GSP file for this area. What will we do? We have a little tool for generate a point grid inside of our tools for GIS. For the command, I'm saying him how to save the file. At this point, he asked me, the file exists, I want to overwrite it, and I do say yes. Now he needs the area. You can use the limits or the point at the left button and right top to define the area. On the right side, you will see that is the grid wide. We are using at this point 100 meters. And that's all. And we say, okay, create the file. He was successfully, and that was what we have. Let's have a look what he produced. You see no grid, a point grid around our drawing, but he produced the file on the left side. The virtual point number, the X and the Y coordinate, rounded on our grid wide. With this file, you go to the official, coming from government or company, a program to officially transform to the new coordinate system. And this program you use may differ of the area where you live, what you want to do. So as a result, you get a second file with the same point numbers and the corresponding coordinate system. When you have done this, you need a new command we integrated in our tool. Sorry, it's at this moment in German. We will translate it. First, you have to select the coordinate system of the source. For this, you use the normal coordinate library integrated in Civil 3D. And a short code for it. Now I can give him the source points, the coordinate system for the target. I use the ETS 89 UTM and also short code. Now I select the target points I generated with the different program, and I tell him, okay, where to write it. The file exists at this point, so he will ask me again if I want to replace it. And last, my name. When I select the source and the target file, he fill the table with the coordinates, find. And then I can say, okay, NTV2 generated. At this point, I have done it. That was all, and we get a new file. It all works fine. With this generated GSB file, we can produce the same as we see above. No, first in this presentation. Okay, a little look at this moment. Useful programs and links. At first, when you are interested in the tools for GIS for generate a GSP file, you can use the first link. Or otherwise, the company Killitsoft has also some tools for NTV2 files, and also they have a library over the whole world. So have a look there, and you will find the e-files using with Cirrus 3D. When you have any question, we will now go to the time of Q&A after this presentation. You are welcome, and thanks for listening.